had a customer come in and they're looking for this hydraulic hose. As you can see, the end of it broke off. Braid got the rubber sheathing got cracked. Moisture got in there and caused the braid to fail. It rusted, and then of course it just comes apart, and then there is no reinforcement for the hose, so it can't hold the pressure. So he says, make me 6 of them like that. So we're going to make 6 of these hoses. First thing we do is take a known fitting of a male size. This is a female fitting here, and of the style that we think it is, and see if that screws in properly, which it does. You know, if it doesn't wiggle much when it's just in the threads, because sometimes you'll have foreign threads that are close, and as it goes in, it'll have a lot of wiggle to it, and even though it screws in, it's not tight. It'll come loose, or it'll eventually blow off. But this fits properly. This is so this is a female JIC swivel. This is a male JIC, and so we know that we verified that this is the JIC fitting. Next thing we look at is the hose, and there is some writing on the hose, and it's a single wire hose, and this one's 1/4 inch. But what we're going to do when we put it together is we're going to just use 3/8 hose, because it is a 3/8 fitting, which that was another thing to verify by putting the male in there, is that we know not only what style of it fitting it is, but also the correct size. So this jumps from a number 4 to a number 6, and in the application that it's going on, which is a snowplow hose, the cost isn't going to be any different, because the jump size always adds a little to the cost. So if the 3/8 hose is a little bit more than the 1/4 inch hose, it'll even out, and the 3/8 hose is not going to create a problem with the application this is going in. If they were held in a bundle or had to go somewhere tight, then we'd want to stick with a hose that's similar in diameter to what came out. So the pressure that was listed on the hose that came in was like 2275, and this 3/8 single wire hose from Gates, this is 6G1, and it's good for 2600 psi. So it pressure-wise, it does exceed what had come in. So when putting together the hose, what I like to do is line it up here, and then put my thumb, or well, it's kind of backwards. So anyway, line it up here, put my thumb there, so I know that when the fitting goes all the way on, it's going to contact my thumb, and I know that the hose has full engagement into the fitting, because some of them are actually really tight to put on, and if you get it on and you only got it in a little bit, and then you go to crimp it, well, it stands a possibility of blowing off. So I use the thumb method by the length of the collar, and put that on, and now we know that's fully engaged. I mean, you can feel a difference also. You can feel the tips of the wire as you twist this back and forth. You can feel it kind of rubbing there, but some, like I said, some go on real hard, and they're hard to twist and hard to feel, but that is one sure way of making sure that it has full engagement. So whenever we cut off a hose with this saw, it makes a lot of smoke. You want to have ventilation. We have this little fan up here that it draws in some air. I mean, not a lot of air, but it draws in some air. And then we have a central ventilation system in here with a tube that comes down, and it's right over here. So if we're cutting off some bigger hose and 4-wire hose, or even 6-wire hose, where the cut takes a lot longer, it makes a lot more smoke, that's when we get that other exhaust fan going. But generally, for a small hose, this one is sufficient. Okay, so we're using the Gates 6G1 hose, which I've written up here, the crimp specs on it. So 6G1, we'll come across. We're going to use a 732 die, and it's going to be crimped at 640 on the readout. So we'll move the readout here up to 640, which this one bounces around. So it's right about there. It's around about 640. It's pretty sensitive adjustment on there, so if the numbers bounce around, it's pretty darn close to what it is, and the crimp diameter should come out within tolerance. So with both fittings put on, we're going to crimp the hoses. And that's how it comes out. Now, if you saw that I stopped in the middle and turned it, it's to flatten out the lines that form from the crimping dies. So as these dies come together in the seams, sometimes it'll create those lines. Let me show you on the other side here. So as you can see, the lines are, there's gaps there, and as we crimp it, they come together. If we go full crimp here, you'll see, whoops, just fell out. But you'll see the lines that it leaves, which, you know, they're kind of sharp. They're not real sharp, but on the 1/4-inch ones, they do get really sharp. So I like to turn it and flatten out these lines so it's got a better finish and a better appearance. Yeah, so that comes out a lot nicer. None of those lines sticking up. Now we'll do the other 5 hoses. Now, clean out the hoses. Got to get that metallic debris out. I want to give somebody a hose that's got metallic debris in it. Okay, 6 hoses done and ready to go. I like making hydraulic hoses. It's a lot of fun.